Hi students, good morning. Today we are going to discuss about the charges and its field. Okay? Today we are going to discuss about the charges. One new topic is here, charges and its field. Charges and its field. This is a new topic, charges and its field. Okay. First of all, we are going to discuss about the charges. Charges. So charges is very intrinsic property of a matter. Intrinsic property of matter. Intrinsic property of a matter. So next, symbol of charge. What is the symbol of charge? Symbol of charge. What is the symbol of charge? Symbol of charge is a Q. Q symbol. So SI unit of charge is SI unit of charge. What is SI unit of charge? SI unit of charge is a coulomb. SI unit of charge is a coulomb. Symbol C. Symbol. So next is here. This charge is a scalar quantity. It's scalar quantity. It's a scalar quantity. It's a scalar quantity. Right. Next is here. What is the conservation of charge? Conservation of charge is meaning charge neither be created nor destroyed. Neither be created nor be destroyed. It can be transferred. Okay, so this is a conservation of charges. And next is the quantization of charge. That's what is the concept? Quantization of charge. Quantization of charge. What is the quantization of charges is here? Quantization of charge is charge always exists integral multiple of fundamental charges. Charge always exists. Always exists integral multiple of fundamental charges. That's why right now Q is equal to plus or minus NE. N is integral, E is a fundamental charge. Okay. So quantization of charge Q is plus or minus NE. Okay. So method of charges, charging methods. Mainly is a charging methods. What is that here? Mainly charging methods is here. So conduction method is here. Conduction method, biconduction method, and convection method, and frictional method. Generally, frictional method. Okay. These are charging methods. So this is charges is generally charges. Two types of charges is here. There will be two types of charges: positive charges and negative charges. Positive charges and negative charges. So positive charges, negative charges. Positive charges is positive charges repel. That's meaning they are like charges. That's meaning like charges repels each other. Okay. Like charges is a repels each other. Unlike charges is a attract. Charges generally two types is. First one is positive charges. And negative charges. Positive charges and negative. And like charges is a repel each other. Like charges repel each other. So that's my example. Plus Q charge repels each other. Minus Q charge, like charges, is a repels each other. Okay, students. And unlike charges, unlike charges is here. Unlike charges attract each other. Unlike charges attract each other. So unlike charges, positive charge and negative charge is attract each other. Like that, negative charge and positive charges attract each other. That's why here, like charges repels, unlike charges is it? No charges, the body having no charges is meaning, what is that? The body having neutral. What is the meaning of the neutral? Sum of positive charges is equal to sum of negative charges in that body. That's why the body is called a neutral body. Negative charged body is meaning what is it? Deficiency of electrons. Deficiency of electrons. Deficiency of electrons in that body. The body having positive charges. Body having positive charges. Excess of electrons in the body. Excess of electrons. The body having negative charges. Neutral body is meaning sum of positive charges, sum of negative charges is equal. Sum of positive charges is equal to sum of negative charges. The body having neutral bodies. So like negative neutral bodies. So negative charged body, positive charged body, and neutral body, like they will depend upon the charges. Okay. So force of interaction between the charges. According to Coulomb's law. According to Coulomb's law, we are going to discuss the force of interaction forces between the two charges. According to Coulomb's law. According to Coulomb's law. Coulomb's law. According to Coulomb's law. What is according to Coulomb's law? For interaction of forces. For example, two positive charges take here. One of the positive charges here. So another one is a negative positive charge. Two like charges is here. Distance between the two charges is R. Okay. Two charges, first charge, second charge. Distance between the two charges is R. These two charges is a repulsive. These two charges is a like charges, that's a repels each other. Repels each other. So when you observe clearly, force on first charge due to second one. So we can write here force on first charge due to second. So this is also here also force on second charge due to first. Force on second charge due to first. These forces acts along line joining of center, not goes to the different directions. This force of attraction and repulsion goes to the different directions. This force acts along line joining center of charges. 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 Is it clear? So, this force of attraction or repulsion between the two charges, force is directly proportional to this force is directly proportional to the product of two charges, Q1, Q2. Q1 and Q2, two charges is here. Force of attraction or repulsion between the two charges is directly proportional to the product of two charges. Question number 1. And number second is here. What is that here? The force of attraction repulsion is inversely proportional to the square of the distance. 1 by r square. By help of these two equations we write now here, you can write here F is proportional to Q1 Q2 by R square. Q1 Q2 by R square. We remove the proportionality. F is equal to K is one of the constants. Q1 Q2 by R square. F is equal to K Q1 Q2 by R square. F is equal to K Q1 Q2 by R square. What is the meaning of the K is here? K is a constant. What is that here? K is here one of the constant value. So K simply right now here. K is here. K is equal to 1 by 4 pi epsilon naught. K is equal to 1 by 4 pi epsilon naught. K is equal to 1 by 4 pi epsilon naught. Now the values, the constant values here. 9 into 10 power of 9 into 10 power of 9. 9 into 10 power of 9. Okay, meter square for Coulomb squares. Newton meter square per Coulomb square. What are the units is here? Constant units. Newton meter square per Coulomb square. Okay, this is very important. K is 1 by 9 to the power of 9 Newton meter square per Coulomb square. This is a force of interaction between the two charges. F is equal to K Q1 Q2 by R square. F is equal to K Q1 Q2 by R square. Okay, students. Let's now we discuss other points is here. Similarities. What are the similarities? Electric forces and gravitational forces. When you observe clearly, some similarities is here between the electric forces and gravitational forces. You know very well. Already we learned that F is equal to K Q1 Q2 by R square. Yes. This is one of the formula according to Coulomb's law. There's another gravitational force formula also is we learned here that it's electric force, and gravitational force formula is that gravitational force F is equal to G M1 M2 by R. It's the gravitational force between the two bodies of the universe. Right? So what is the similarities is there between these two formulas? So you have observed clearly here. So first one similarity. What is the first one similarity? Okay, student. What is the first one similarity is? So first one similarity is there. First one is force acts in these two situations also, two formulas also. Two phenomena also is there. Force acts along line joining of center. Okay, students. In these two conditions also. So next one is second is here. So inverse square law. Store from the inverse square law. Inverse square. What is inverse square? F is proportional to 1 by R square. These two are similarities between these two formulas. Gravitational force and electric forces. So what is the difference? What is the difference is there? When you observe the difference is here. Gravitational force is the only attractive force. Gravitational force is the only attractive force. But electric force is a attractive force as well as a repulsive force. Okay, students. This is first one. And second one is what is that here? This gravitational force does not depend on the medium. The gravitational force does not depend on the medium. But electric force depend on the medium. Electric force depends on the medium. It's just like the similarities between these two electric forces and the gravitational forces. Okay, students. This is the main basic information about this chapter. Okay. Next class we are going to discuss about this some problems from this chapter, from this concept. Okay. Bye students. Next class we will discuss. Okay.